Hello everyone, in today's presentation we'll be looking at CosmosDB user-defined functions, and today's examples will be generating an array from a string, creating a derived calculation, creating a derived tag or result, and then looking into an edge case. Hopefully from these 4 examples there might be something that you can glean that might help you with your user-defined functions. So jumping into CosmosDB, creating a user-defined function would be located here on top by this gear icon and clicking new UDF. We would give the user-defined function an ID, and when we do, it would appear here on the side under user-defined functions. And then basically using JavaScript we can create a function case that takes in a parameter and operates on that parameter. Then we can call that parameter within a SQL query and get the desired results based on our use cases and logic. For today's example, we'll be operating on top of a movies collection, and this collection is about 2,700 records long, and it contains records pertaining to the movie, so like movie name, budget, revenue, genre, so on and so forth. Our first example would be to create a list from this movie's record, and we're going to use the genres as a input variable. So we'd notice here that this genres here is actually one string split by a pipe, but our example wants to take this string and create a JSON array from this string. So what our user-defined function does is that it takes in a text and a separator, and it basically splits the text by the separator. And the result of this function is an array, and because we're querying it, it will come back as a JavaScript array. So let me run this query over here again, and you'll be able to see the results coming. So we have the movie name, which is the ID, the genres, so this is what was originally in CosmosDB, and then we have this genre list, which is an array version of this attribute over here. And to call the user-defined function, we basically said UDF dot, and then we have the user-defined function name split to array, and we have passed in the genres and the separator. So this is a good use case for when we need to manipulate strings. In this example, we manipulated a string and returned an array. But there might be other examples that you might use, and I think using this might be best in some kind of a CSV or flat file based application where you're saving the header row in CosmosDB, and if there's another application that needs to count how many columns are in that header row, maybe you could use something like this to actually split it out into an array and then maybe calculate the length. That might be a good use case. But for our second example, what we're going to do is that we want to calculate the profit from the movie, so the revenue minus the budget. And when we initially run this query, we get back a result that just has the names. And looking further, it's because of how we actually loaded the data into CosmosDB. Loading this data, you'll see that the budget and the revenue as well, those two fields are actually coming in as strings, which could be fixed if we just reload the data properly. But I think for this case what we wanted to do is that we just wanted to query out the data, and we tried using a cast, we tried using a convert, but both of these aren't supported within the Cosmos SQL API. We'll just say incorrect syntax. Rather, what we need to do is use the system functions to run this conversion from a string to a number. So we have a system function called string to number, and there are other system functions for string manipulation, mathematical or array type functions. I'll leave a link. But what we're doing here is that we're just doing a string to number on the revenue and the budget, and then because we're doing that and it comes through as numbers, when we run the query, it will actually bring through the profit with the movie ID, as we can see here at the bottom. But what we wanted to do is that we wanted to create a user-defined function that does basically the same thing. So we have create profit here, which takes in revenue and budget as a parameter, and it passes it to a float, does the subtraction and returns the result. And we call it here calculate profit and pass in those parameters. So when we run this query, we'll actually see the same results as the previous one on top. The only caveat is the amount of RUs we spent to run this query using that user-defined function. So the user-defined function used 5.23 RUs, whereby if we ran the query just using the system-defined, the system function, we would actually get a less costly query. So this one returned back 2.55, almost or nearly about half of the amount. So when in doubt, it's better to use a system function than a user-defined function, because the system function would be more cost-effective. So looking at our fourth example, what we wanted to do in this user-defined function is to actually use the profit amount, right? The amount that came back when we took the budget off of the revenue, and we want to create a derived tag. So we want to say, is it a profit if it's greater than 0? We broke even if it's equal to 0, and if we get an amount that's less than 0, it's a loss. And then just as a guard clause, we have not applicable. That's just in any cases whereby there are any documents that don't have a budget or a revenue tag according to it. So we do have a guard clause over there. So I have two examples here going further just to explain a case. So one case we could do is that we could use the user-defined function that calculates the profit, return back the profit, and then pass that user-defined function in the calculate budget user-defined function. So one function to calculate the amount and the other function to associate a tag based on that amount. So you can pass in a user-defined function in another user-defined function. And when we run this, we do get a result back with the amount as well as the tag associated with that amount. But then again here, the RUs spent was about 130. In the second example, what we're doing is that we're using the system function to basically pass the revenue and the budget as a number, and then we get a profit from that, and then this entire value here is passed into the calculate budget outcome user-defined function. And when we run this, we also get the same or similar result in terms of the movie ID, the profit, and whether we broke even or it was a loss, a profit, so on and so forth. But if we go into the query stats, it's significantly cheaper than the one above where we used the user-defined function. So here we can see the more user-defined functions we run, even though we can put a user-defined function in a user-defined function, it's still quite costly. So in terms of user-defined functions, the less user-defined functions we use and the more system functions we use, or the more inbuilt functions we use, the more cheaper our queries will be. But this doesn't stop us from using user-defined functions, because there might be some functionality that is not inbuilt that you'd want to use. So that's our third example. And going further in this third example, we saw that in the calculate budget we had split out the amounts or the use cases and then calculated the tags, but we wanted to see if it was possible to do such within a CosmosDB environment using the inbuilt environments. And there is a way to do this, though there isn't a case when statement, but we can nest the ternary operators within CosmosDB. And if I run this, which will basically do the same logic that checks the amount, we'll get a result which has the same values as the previous one. And when we look at the query stats, it takes 12 RUs. So again, significantly less RUs to query the data using the inbuilt functions or the inbuilt query processes. And we can go even further. We can run this within a subquery. So inside, we're running a query to get the movie ID and whether it was a profit or loss, as well as the amount. But then on the outside, or the outer query, what we're doing is that we're filtering all of that by profit. So we're only getting back 1,000 movies where the result was a profit. And I could run this query and we see here that all of these results are profits. And then if I go into query stats, we would notice that this query took about 20 plus RUs to run, which is still significantly cheaper than when we ran within a user-defined function. So user-defined functions, though they have great functionality, it's high RU cost, but it's not all doom and gloom, because there are some use cases or some edge cases where we want to run user-defined functions, even though running the entire thing might be less. So I have this doc processor user-defined function, which basically takes an entire document as a parameter. And what it does is that using JavaScript, we're able to actually count the amount of attributes within that document. And why this would be beneficial is because CosmosDB, the document database, allows us to save documents of different schemas. And there might be a case where we want to find out what is the biggest schema document, or which document has the most amount of attributes, or if all the documents, what is the average amount of size or attributes per document. And we might use something like this to calculate the attributes within the documents. So I'll run this one on top here, which basically takes the ID and it runs the user-defined function and returns how many attributes was in that that document. So I'll run this query, and the results, we get the movie ID, and majority of them have 29 attributes. And if we go into query stats, this took about 84 RUs. But the second query is one above that. We want to find out which document within this collection has the most attributes, or the count at least of it. And we find out that the largest document has 30 attributes. So this is a good use case to find out at least attribute document sizes, but there might be other use cases. But then this one took about 1,000 RUs to run, so that's quite a hefty cost to find out that that result. And note that if I query the entire collection, which I did before as well, we'd find that to query the entire collection is 10 RUs, which is about 100 times less than this entire process here. So maybe it might be a better use case to query the entire document and use some analytical tool to run that calculation in terms of which document is the biggest, or which document doesn't have this attribute, or what schema, so on and so forth. But then again, that is up to you. So in closing, using CosmosDB user-defined functions allows us to have large amounts of functionality, but it comes at the cost of RUs. And because of this, we need to re-look into how we query the data, as well as how we load the data in the first place, so that whenever we run our queries, it's as efficiently as possible, whether we use a user-defined function or a system function to pull that, or whether this gives us opportunities to look into other tools to query the data, or in the case of finding the best and efficient way to pull the data. But I'm open to hearing your thoughts and your ideas if you have any ways in terms of how to run a user-defined function as efficiently as possible, or what other workarounds could we find in terms of running calculations or derived columns from CosmosDB. Open to hearing from your thoughts, and thanks once again for your time.